Hi, my name is Robert Parker. I'm the current president of Consumer Products Manufacturing Enterprise here at Michigan Tech. I'd like to tell you a little bit about our project work. So, right now we have projects broken into 3 different groups. We have environmental sustainability projects, industrial optimization projects, and then also product innovation projects. So, in our product innovation group, we are working on using NanoMag, which is a Fix-A-Mold and magnesium sheet with fantastic damping properties, in several different sporting applications. We're looking at using it to improve puck control within hockey stick blades, and we're also looking at it to reduce damping and increase speed potential in downhill skis. Our third product innovation group is working on creating an electric dish scrubber. This is to improve washing dishes by hand, make it easier to scrub grit and grime off of your pots and pans when you do have to wash things by hand. So next is our industrial optimization group. We are currently working with the Kimberly-Clark Corporation and the Dow Corning Corporation. Our Kimberly-Clark project is looking at reducing friction within their folding techniques, one of their materials in their garment line. And so what happens is we're looking at different folding techniques themselves, and then also looking at different coatings to reduce that friction. This will improve maintenance and also improve their folding techniques overall. We're also looking at changing pigmentation changeover with Dow Corning Corporation. Right now they mix sealants. They have black sealants, white sealants, red sealants, and where there's a lot of waste incurred when there's going from a black sealant to a white sealant. So we're looking at reducing that overall waste. Some of the things we have is a diverting line, so you offset the cost of packaging waste, inline spectrophotometers, so you don't have to package a material at all, and then we're also looking at different static mixing options. Right here is an example of one of the static mixing elements that could potentially be used, and then here is all of the different testing that we've done with different static mixing designs on a bench scale. So our environmental sustainability projects, we have 3 groups once again. The first group is the Biochar Filtration System and the Pavlis Institute, and we are building a biochar reactor. So what a biochar reactor does is it takes a woody material and makes it into charcoal through a pyrolysis process, which is burning the material in the absence of oxygen. This material has a very high surface area and can be used to absorb chemicals out of water that are hazardous for people to drink. So what we're doing is we're creating potable water for people in India. We actually do have students that are going to be going over with the Pavlis Institute to help implement this system and give people in developing countries clean water to drink. The second one, we're working with optimizing their aquaponics system in the Dow greenhouse. They have an issue right now with whiteflies and thrips, which are bugs that are eating the plants, and we're looking at 100% natural ways to reduce those bugs, or pest management systems, so that we don't harm the fish at all. We're also looking at a solid separators because fish waste can actually fall out transfer pumps throughout the system. Finally, we are working with the Kimberly-Clark Corporation on another project. This is waste repurposing. We're looking at alternative end routes that are more sustainable, create a better life cycle for one of their waste materials, and then also we're looking at the best way to save the most money while improving that life cycle. So once again, my name is Robert Parker. I'm the president of Consumer Product Manufacturing, and thanks for listening.